Hi students and friends, welcome to the channel Learn and Teach by Ayaz. This video lesson is about the topic reversible reactions and equilibrium. Syllabus learning outcomes are for the 2023-25 version for both CAIE 5070 and IGCSE 0620. So these are the learning outcomes for this video lesson. State that a reversible reaction in a closed system is at equilibrium when the rate of the forward reaction is equal to the rate of the reverse reaction. The concentrations of reactants and products are no longer changing. Predict and explain for a reversible reaction how the position of equilibrium is affected by changing temperature, changing pressure, changing concentration, using a catalyst, using information provided. Recall the definition of a reversible reaction. The reactions that can be reversed or take place in both directions are known as reversible reactions. That can be reversed or take place in both directions. Are known as reversible reactions. We also know that a reversible reaction can be represented by a sign. Now I am going to talk about how a reversible reaction reaches to dynamic equilibrium or equilibrium state. We all have experience of buying mineral or distilled water bottles like the one shown here. This distilled water, also known as battery water. It's a pure water, does not contain any impurities. You can see some droplets of water at the neck of the bottle. In this area, you see these droplets of water. You have seen these enclosed and packed bottles also. But the question is that why these droplets are at the neck of bottle. Recall that water has slightly volatile nature. Water is slightly volatile. That is, water molecules leave the surface of water below boiling point, and it can happen at room temperature. But the rate will be higher during summer and hotter days. As you can see here that the bottle is closed, so these water vapors will cool down and condensed back into the liquid state. So you write here, due to this reason, we see these droplets at the neck of the bottle. We can see the reverse process, which is liquid water conversion into vapor state and then condense back into the liquid state. So you can show this through this reversible sign. And when this happen in a closed bottle system, like here, we can say that a reversible process reaches to equilibrium state. It is a reversible process which is to equilibrium state. When a reversible reaction reaches to equilibrium state, it means that the rate of the forward reaction is equal to the rate of the reverse or backward reaction. When a reversible reaction reaches to equilibrium state, it means that the rate of the forward reaction is equal to the rate of the reverse or backward reaction. We have also noticed that the total concentration of water in the bottle will remain 1 liter or same. If it is 1 liter, the volume will not change. So you can also state that for a reversible reaction in equilibrium state, that when the concentrations of reactants and products are no longer changing or become constant. For a reversible reaction in an equilibrium state, the concentrations of reactants and products are no longer changing or become constant. Effects on the position of equilibrium. Now let's talk about the effects on the position of equilibrium for a reversible reaction at equilibrium state. First one is changing temperature. Take an example. for the reaction between reactants A and B to give product AB. This is the reaction. Forward reaction is exothermic, which means the reaction releases heat. Delta H is equal to minus. So if we increase the temperature of this reaction, the equilibrium will shift to the reactant side. Increasing temperature shifts the equilibrium to reactant side. Reason backward reaction or backward direction is endothermic. Or you can also write that forward direction of product side is exothermic. Backward is endothermic, or forward is exothermic. Let's talk about the effect of changing pressure on the position of equilibrium. Remember, this effect is applicable to gas states only. We'll consider the same reaction. Here the total number of moles of gases on reactant side is 2. 1 plus 1 is 2. The product side is only 1 mole of gas. So if the pressure is increased, then the direction of the equilibrium will shift towards the side with less number of moles, molecules, or even volumes of gases. And in this case, it should be the product side. Increasing pressure shifts the equilibrium to product side because less number of moles, molecules, or volumes of gases on product side. You can write the reverse argument. For this one, like higher number of moles on the reactant side changing concentration. This is very simple. If we increase the concentration of the reactants, the equilibrium will shift towards the product side. I'm writing the same reaction. Increasing the concentration will shift the equilibrium to product side. Reason is simple: to decrease increase in the concentration of reactants. To decrease the concentration of reactants, or to increase the concentration of product. There will be no effect of catalyst on the direction of equilibrium. This is because catalyst increases the rate in both forward and backward directions. Try these past paper questions by yourself. I will share the answers in the next video lesson. We have first question: ethanoic acid is manufactured by the reaction of methanol with carbon monoxide. An equilibrium mixture is produced. This is methanol, carbon monoxide, and this is ethanoic acid. State two characteristics of an equilibrium. The purpose of the industrial process is to produce a high yield of ethanoic acid at a high rate of reaction. The manufacture is carried out at a temperature of 300 degrees centigrade. The forward reaction is exothermic. Using this information to state why the manufacture is not carried out at temperatures below 300, above 300 degrees centigrade. Ethanoic acid is manufactured by the reaction of methanol with carbon monoxide. This is the same question. In part C, they are asking, complete the table using only the words increases, decreases, or no change. Effect on the rate of forward reaction, effect on the equilibrium yield of ethanoic acid or CH3COOH. Adding a catalyst, decreasing the pressure. Ethanol is manufactured by the reaction between ethene and steam. The conditions used are 300 degrees centigrade, high pressure, and a phosphoric acid catalyst. The reaction between ethene and steam is reversible. For the forward reaction is exothermic. This is ethene and steam. The product is ethanol. An equilibrium mixture is formed when the reversible reaction happens in a closed system. Predict what happens to the amount of ethanol in the equilibrium mixture if the temperature is decreased and the pressure remains constant. Explain your answer. You have to give prediction, then give explanation. Ethanol is manufactured by the reaction between ethene and steam. This is the same question. In the next part, what they are asking, predict what happens to the amount of ethanol in the equilibrium mixture if the pressure is decreased and the temperature remains constant. You have to explain your answer. So here's the summary of this video lesson. A reversible reaction in a closed system is at equilibrium when the rate of the forward reaction is equal to the rate of the backward or reverse reaction, and when the concentrations of reactants and products are no longer changing or become constant. Any change to a reversible reaction at equilibrium state will force the reaction to counteract that change. This will lead to a shift in the direction of equilibrium. Thanks for watching. Press like, give comments, and share my video. For more videos, subscribe my channel and press the bell icon.